This is a video on unit conversions using dimensional analysis technique. This technique or method involves conversion factor and also the cancellation, the unit cancellation. That's why sometimes also known as factor label method or unit factor or unit analysis method. Conversion factors are ratios that we get from equivalents. For example, foot and inches. 1 foot is 12 inches. Now 1 foot equals 12 inches. This is just an equivalent. Equivalent is a true definition or a statement. There are two ways to write this equivalent. 1 foot equals to 12 inches. We can say that 1 foot has 12 inches, or we can say there are 12 inches in 1 foot. When you put the units here, since the 1 foot is equals to 12 inches and since 12 inches is equals to 1 foot, when you put them in this way, the ratio becomes equivalent to 1 because it's only the units which are different, but the ratios are expressing the same quantity. The basic step to solve these problems with dimensional analysis is to start with given over 1. The reason we put 1 at the bottom is just to show that we are working with fractions. It doesn't change anything since it is unitless. Then you multiply with the appropriate conversion factor. Conversion factor, you may be using 1 or you may use 2 or 3 conversion factors depending on the complexity of problem. But how do we figure out the appropriate conversion factor? How do we know which one is the appropriate conversion factor? So that depends on what do you want to find in the problem. For example, if you have to find feet in a problem, you're going to use this conversion factor. So you're converting for inches to feet because you have to find feet. So desired unit is going to go at the top. Now if you have to find inches, then you are going to use this unit. The desired unit goes at the top. Desired unit, the unit you want goes at the top, and the unit you want to cancel out goes at the bottom, meaning in the denominator. These are the steps here to solve problems using dimensional analysis technique. Make sure you read the problem carefully. You look for what's given in the problem, and then you also look for what you need to find out, because your direction is always you start from the known, which is the given quantity or the starting unit, and then you move towards the direction of unknown, the unit that you want to find out or you want your answer in. That is your ending unit. So always going from known to unknown. As I just said, that you multiply given over 1 with appropriate fraction. Now some places you might see that fractions are enclosed in a box. That's your choice. If you want, you can put them in a box. Again, what is an appropriate fraction? Appropriate fraction is the one where you have a desirable unit at the top. Desirable unit is the one that you want to see in your answer. How do you get the appropriate fraction or those fractions? You get them from equivalence. Once again, desirable unit is the unit that you need to end your answer with. That's an ending unit. Then the next step is you cancel the same units in the numerator and the denominator. That's the unit cancellation, extremely important. At the end, you want to make sure that you're left with the units you wanted. Here in this step is the one where students usually get mixed up. They get confused whether you have to multiply or divide. So when you are at the math part, the solution part, everything in the numerator needs to be multiplied. Everything in the denominator needs to be multiplied as well. But the numerator and the denominator put together, you divide them. Your calculator can give you the answer in correct scientific notation. However, you can't find significant figures using the calculator. Usually for these problems, you look at the given, and whatever is the significant figures in the given is the significant figures in your answer. And don't forget to write the correct unit when you answer the final answer. These are my quick notes or summary of this topic. Now let's do some examples. Please take time reading them. 0.34 liters, and you want to find out how many milliliters are there in 0.34 liters. So the basic definition of liter is 1 liter is equivalent or equals to 1000 milliliter. Again, you can write this in two ways. 1000 milliliters makes 1 liter, or you can say in 1 liter there are 1000 milliliters. Once again, follow these steps. You're going to start out with given over 1 times conversion factor, then you cancel units, you do the calculation, you put your answer with correct units. So I'm going to start out with 0.34 liters because that's my given, over 1, and you put it over 1. And why are we doing that? Because that's how we start. Now I'm looking for a way to get rid of my liter because I don't want liter in my answer. What do I want in my answer is milliliter. So which fraction should I pick from here? This one or that one? Well, I want to get rid of liter. So liter here is in the numerator. So the next fraction should have liter in the denominator. So this is the one I'm going to use. Alright. So here you go. Liters and liters get cancels out. When you do the math, you're going to get 340 milliliters. Don't forget the units and don't forget the sig fix. 2 sig fix here, 2 sig fix here. Let's do the other problem. 5.2 decimeters equals to how many centimeters? The basic relationship between decimeter and centimeter is 1 decimeter is equals to 10 centimeters. We can make two fractions here. Now which fraction will help us getting rid of decimeter? Because I don't want decimeters in my answer. What do I want? I want centimeters in my answer. So let's start with the given. My given is 5.2 decimeter and then over 1. I'm going to multiply with the appropriate fraction. I don't want decimeter. So decimeter in the fraction which I pick, decimeter should be in the denominator. So this is the one I'm going to pick. 10 centimeters equivalent to 1 decimeter. You cancel out the units. When you do the math, you are going to get 52 centimeters. You follow these steps, given over 1 times conversion, appropriate conversion factor. Again, if you want, you can put them in a box, the appropriate fraction in a box, but you don't have to. Let's do another problem. 250 micrograms. How many grams are there in 250 micrograms? Well, what do we know about micrograms and grams? We don't have a direct conversion factor to convert from micrograms to grams. So, but we do know that micrograms and grams, they both are connected through milligrams. So milligrams here, right, and milligrams here. We know 1 milligrams is equals to 1000 micrograms. And also we know that 1 gram is equals to 1000 milligrams. These are the equivalent that we should know. And then you make the fractions for each equivalent. For this one, again, 2 possible fractions, which are the conversion factors. So you can say either the fractions or you can say conversion factors. Once again, this equivalent, these are the 2 possible conversion factors. So we are going to go from known to unknown. Again, what is given? What do we know? 250 micrograms. This is micro over 1 times. Now, what do I want to cancel out? I want to cancel out micrograms. So look for micrograms here. We have a microgram in this equivalent. Now, which fraction should I pick? This one or this one? Well, I don't want micrograms in my answer. So I'm going to pick this fraction, because by using this fraction, I'm able to cancel micrograms and micrograms. That's the unit I wanted to eliminate. However, I'm not going to stop here because we are asked to find grams, not milligrams. Well, let's look at the relationship between milligrams and grams. Here you go. Again, which fraction should I pick from here? I want to get rid of milligrams. So I'm going to use this fraction. Okay. And you cancel milligrams and milligrams. When you do the math, you're going to get this many grams. So in order to put the answer in scientific notation, You can move this decimal 1, 2, 3, 4 places. 2.5 times 10 to power negative 4 grams. You might say, Miss, we could have found the answers just by multiplying or dividing by tens or moving decimals. You're right, but moving decimal points method work only for metric units with same base units. Okay, you can't use it all the time. Unit analysis method can be mostly used anywhere with any system of units. Now we are going to spiral back to this technique when dealing with moles, stoichiometry, and also gas problems. And here, dimension analysis or factor label method works for any system or anywhere. This is what I just said. You can use this for complex problems, simple problems within the metric units, conversions or conversions between metric and English, or conversion between English units and English unit. Again, what is the limitation of using the method of moving decimals for unit conversions? This is the limitation, that this method of moving decimal can work only when dealing with the metric units, and those units have same base only, have to have a same base. Now let me do another problem, one more problem involving metric and English unit both. So here you have a metric unit, centimeters, and you have feet. We want to find out how many feet are there in 161.5 centimeters. So again, here we are using these two conversion factors. For this equivalent, we know 1 inches is equals to 2.54 centimeters. Then we also know that 1 feet is equals to 12 inches. So you make two conversion factors here. So one equivalent makes two conversion factors. We're going to start out with given 161.5 centimeters over 1. Now, do I need centimeters? No, I don't need centimeters. I do need feet. However, I don't have a direct connection between centimeters and feet, but I can see that inches and centimeters, they are connected. So I'm going to pick this one here. 1 inch is equals to 2.54 centimeters. Centimeters and centimeters gets cancelled out. Now, do I need inches? I don't want inches, but what do I want? I want feet. So let's see the relationship between inches and feet. Here you go. Now I'm going to use, since I want to cancel inches, I'm going to use this one. So 1 foot is equals to 12 inches. Inches and inches gets cancelled out, and you are going to multiply everything at the top, multiply everything at the bottom, and then you divide both of them. So 161.5 when you multiply when the top, and then 30.48 you're going to get when you multiply this. Now when you divide both these numbers, don't forget to put the units. It is feet, 5.299 feet. So you see, only the feet is left, rest of the units are getting cancelled out, which is equivalent to 5.3 feet. Don't forget the units. Always remember to use the units. I want you to solve these problems on your own. Also, I'm going to go over with them real quick. Let's do the first one here. I already have solved them beforehand for you. Now 10.5 moles, you want to convert them into millimoles. You have an equivalent here. You're going to follow the same steps from an equivalent. Now 1 mole is equals to 1000 millimoles. From this equivalent, you make two conversion factors. You follow the same process. You start with the given over 1 times appropriate fraction. Now appropriate fraction is the one where you can cancel out the units which you don't need, and you are left with the desired unit at the top. So your desired unit is millimoles. You did the math. You're going from moles to millimoles, and you get this answer. All right. Now let's do the second one. Here 35,000 centimeter cubes too. You have to find how many liters are here. We know this equivalent relationship, 1000 centimeter cube is equals to 1 liter. That's the basic unit. As usual, we start out with the That's the basic definition of centimeter cube and liter. Now, as usual, we start out with the given. Our given is this over 1. Looking for a way to get rid of cubic centimeter. So, because you don't want cubic centimeter in your answer, what do you want? You want liters in your answer. So, which fraction will you pick? You're going to pick this fraction because you want liter, the desired unit at the top. Unit you want to cancel is at the bottom. So, from centimeter cubes or cubic centimeters to liters. Then you cancel out the same units in the numerator and denominator, and you're left with only the liters. Now here, decameter, 8 decameters, and we want to find out how many decimeters are there in 8 decameters. We rarely use deca and deci, but let's decipher this. You're using two conversion factors here because deca and deci both are connected by base unit meter. So meter here. So they are not showing the direct relationship. So it's going to go from decameter to meter to decimeters. Once again, you start out with the given over 1, and then you do not want decameter in your answer. You're going to pick this fraction because this is decameter in the denominator. You cancel decameter. Now you're left with meter. But you don't stop here because they're asking you to find answer in decimeter. So now we need another conversion factor. So we are going to use this equivalent. 1 meter is equals to 10 decimeters. When you made the fractions, this is an appropriate fraction because using this fraction, you are able to cancel meter and meter. You are able to keep decimeter because that's the one you want in your answer. Let's do the fourth problem here. 250 micrograms is equals to how many kilograms? Now what you have here is, this is the one equivalent, this is another equivalent. Again, they are not directly connected to each other. That's why using two conversion factors, these are the two equivalents. 1 gram is equals to 10 to power 6 micrograms, and 1 kilogram is equals to 1000 grams. So what is common in between these two is grams. Grams is common in between micrograms and kilograms. Now you're going to go from micrograms to grams to kilogram. We start out with the given. Again, given is this, given over 1 times. Now we look for the equivalent or the unit factor, which is talking about micrograms. So this is the one with the micrograms, but you do not want micrograms in your answer. That's why you pick this fraction. You cancel that out, you're left with grams. Again, you're not going to stop here because you want your answer in kilograms. Now we are going to use this equivalent and pick the fraction from here, or the unit factor, unit conversion factor. That's going to help in cancelling out grams. So here we don't want grams, so we pick this one. Grams and grams cancel out, and now you're left with kilograms. That's what you want in your answer, kilograms. You multiplied the top, you got this. You multiplied the bottom, you got this. Now this isn't here, this is a regular notation. To write in a scientific notation, you have moved your decimal to the right, and you got the answer in scientific notation. Here also significant figures is correct as well because it is 2 significant figures here and 2 significant figures here. Problem number 5 is unit conversion of time. We want to know number of seconds in 7 days. 7 days is equals how many seconds? So we are going to go from days to hours to minutes to seconds. So we are going from bigger to smaller to smaller to smallest unit. So you write equivalents for the basic relationships between days and hours, between hours and minutes, between minutes and seconds. We know 1 day is equivalent to 24 hours. We know 1 hour is equivalent to 60 minutes, and 1 minute is equal to 60 seconds. So these 3 are the equivalents, and we make the fractions, 2 fractions from each equivalent, and you use the appropriate fraction to cancel out the units which you don't need and to keep the units that you need. So starting from given over 1, 7 days over 1. You want to cancel days. So this is our relationship here between days and hours. You pick from here. You want to cancel days. That's why you have picked this fraction. Day and day cancels out. Next one, you don't want to stop here because that's not the answer unit which they are asking the answer. The answer needs to be in seconds. Now hours, which one shows hours here? This one. 1 hour has 60 minutes. Again, we want to cancel out hours, so you have picked this fraction. 60 minutes over 1 hour. Hours and hours gets cancelled out, right? Now you're left with minutes. Now, you don't want to stop here. We have one more step to go. You are doing 1 minute equals to 60 seconds. That's what you are using. So 60 seconds over 1 minute. You want to cancel out minutes and you want to cancel out minutes. So ending unit is seconds. You always want to make sure that rest all units are cancelled except the one that you want in your answer. So you see all those other units were cancelled out. Only the second is left. Hope this video was helpful. Thanks for watching.